All right. Continuing on with section 3.2. Hopefully this is the last video. We'll see. I got 15 minutes, so we'll see. Formulas given on the AP exam. Actually, in class, I will give you guys the actual AP formula sheet, finally. I could have given it to you earlier, but there wasn't really much on there to help us up to this point in time, but now there's a couple things. And you're going to find that the formula sheet has got a lot of stuff that we're not going to use. And then when it has some stuff that you want it, that you need, it's kind of hard to find because there's a lot of crap mixed in with it. But it doesn't have z-score formulas. It doesn't have, the upper and lower fence formulas. But it does have these two, which might be useful. It has the formulas for S, standard deviation of the residuals, and R, but you're probably not going to ever use them. Standard deviation sigma, again, but you're probably not going to use those a whole lot. But these two might be used. We have data on an explanatory variable x and a response variable y for n individuals. From the data, calculate the mean of the x's and the y's and the standard deviations of the x's and the y's of the two variables and their correlation R. So if you have those 5 pieces of information, then the least squares regression line is the line, boom, and it has a slope of this, and it has a y-intercept of this. So what does all this mean? Basically, if they give you R, and they give you the standard deviation of your y's, and they give you the standard deviation of the x's, your slope is equal to that calculation. It's basically, and there's kind of an interpretive way to kind of look at this. I'm not going to go into it. I think it mentions it in the book. And if you want me to make a video of it, you can. But I can. But it's really not that important, in my opinion. And then once you have the slope, you can find the y-intercept by using this formula here. And there is an important point I want to mention here. When you have a linear regression equation, you're guaranteed that that line is going to go through the point. Let me write it down. X hat, y hat is always on the least squares regression line. You're not guaranteed that there's any data point that's on the least squares regression line. However, the mean of your x's and the mean of your y's will guaranteed be on that least squares regression line. As just a visual illustration, like if I got points like this, obviously my least squares regression line is going to kind of go right in between them, kind of, right? None of my data points are on the line. In fact, usually none of them will be exactly on the line. However, if you were to calculate your x bar and your y bar, that point is guaranteed to be on the line. That's kind of important because a lot of times not a lot of times, but sometimes a multiple choice question will require that you know that. But if you have your b value, if you have your slope, and you want to find your y-intercept, basically, y equals a plus bx. So if you know b, and you know the mean, and you know the y-intercept, the mean of your x's and the mean of your y's, if you plug all those in and solve it for a, you get this. So if I plug in my mean, because I know that's a point, I'm having a hard time talking here, guys, I'm sorry. If you plug that point into that formula, y bar equals a plus b x bar. If you want to solve it for a, you just take y bar minus bx bar. So that's where these two equations come from. Okay, this one I didn't really prove. This one I kind of talked about with the slopes. But if you have this information, you can find the least squares regression line. That's kind of like the third way to find the least squares regression line. The first way is with your calculator. The second way is with a computer output, very important. And I would say maybe once on every 4th year on the AP test, you might see something kind of like this. But I actually often test on that, so you should know it. Does seat location affect grades? Many people believe that students learn better if they sit closer to the front of the classroom. Does sitting closer cause higher achievement? Or do better students simply choose to sit in the front? To investigate, an AP Stats teacher randomly assigned, so we're assigning people to seat locations. So are we doing an experiment? Yes, we are. If we're doing an experiment, can we prove causation? Yes, we can. Okay, if you don't do the experiment, you can't prove causation. There could still be a relationship, but not a causal one. At the end of the chapter, he recorded the row number and the test score for each student. Least squares regression line was performed on the data. The scatter plot and regression line were added. A scatter plot with the regression line added and a residual plot. So there's a very weak relationship, but there seems to be a general negative pattern, meaning the closer you are, the slightly better, a lot of variability, but a little bit better your scores were. And then the further you were away, the slightly lower your scores were, but a lot of variability unaccounted for by the model. And the residual plot kind of shows no pattern. So it looks like a linear model is appropriate. Find the mean standard deviation R, and the mean and standard deviation of your test scores are, and the correlation is this. So if I give you those 5 pieces of information, we can use these equations to find the least squares regression line. So we're predicting scores. So let's find the slope. Slope is B equals R S sub y over S sub x. R is negative 0.218. We got to show our work, or we lose points. 10.135 over 1 point whatever. Oh, there's no way I'm going to remember that. All right, I paused the video because I had to go back and forth like a million times. My short-term memory is not real good. So I put in those values into the calculator, hit enter, negative 1.12. And then to find my y-intercept, that is a equals, and I could just look at my formula sheet, y bar minus bx bar. Y bar is 8. I guess I'll put in y bar minus bx bar, which is y bar 81.2 minus your b, negative 1.12 times x bar 4.033. Put this in my calculator. Hold on a sec. All right, so y bar minus my slope times the x bar, 85.7. 85.7. So there's my slope, there's my y-intercept. So my predicted score, my score prediction, test score prediction, is equal to negative 1.12 times my row number plus 85.7. Okay? So the slope says for every row I increase, for every row I move back, looks like my score is going to decrease by about 1 point. And then if you're at 0 row, your test average would be an 85.7. But again, this is not a very good predictor. I bet you the S, the standard deviation of the residuals, is pretty large, probably right around 15 or maybe even 20. I don't have the data, so I can't calculate it. Anyway, that's all they asked. Show your work. There it is. All right, we're at 9 minutes. Got one more page to talk about. I guess let's just, I think a lot of this has got some pretty involved ideas. I'm going to stop the video and do one last video for the last part. All right, thank you.